Today we were reviewing some skills that you learned in 6th grade, evaluating expressions and solving one-step equations. So we started with evaluating expressions. And to evaluate expressions, you just put the numbers in for the given variables and follow the order of operations. In number 1, it says x is 7 and y is -2. So we just replace the x with the 7 and the y with the -2. Remembering that 2y means 2 times y, so 2 times -2. Order of operations says we multiply first. 2 times -2 is 4, and then 7 plus -4 is 3. In the second one, remember -x means -1 times x. So I'm going to put -4 in for x and -6 in for y. Multiply, -1 times -4 is 4. And then 2 times -6 is -12. 4 minus -12 gives us 16. Number 3, I'm putting an 8 in for x and a 2 in, or -4 in for y. Remembering that that fraction bar means division, but before I can divide, I need to multiply the denominator. 2 times -4 is -8, and 8 divided by -8 is -1. And finally, I have a is -2. And I usually put my variables in parentheses. So I have -2 to the second power plus -3. So -2 times -2 is +4 plus -3 is +1. And then we talked about some socks on hangers and what do we notice and what do we wonder. And the big thing we came up here was that the red or pink socks here, it was balanced. The blue socks were not balanced. These two look the same. They're equal. This one looked different. This blue sock looked different. Almost looked like something was in it. So we're finding a solution to an equation, and a solution to an equation is a number that can be used in place of the variable to make the equation true. And we started with hanger diagrams. And it said write an equation for each hanger. Find a solution to each equation. Use the hangers to explain what the solution means. On the left side of the hanger, we have 6 ones. And on the right side of the hanger, we have a W plus a 1. And since that's balanced, those two things are equal. So our goal is to find what W equals to balance that hanger. And the way we did that was we thought about, well, I have this extra one here, but I can't just get rid of it here. I also have to get rid of it on the left side to keep my hanger balanced. And that means that these 5 ones match up with that W. And what that looks like algebraically in our equation is we took the 1 away from the side with the W, and we took the 1 away from the side with the 6, and we have 5 equals W. Or we could say W equals 5. In the second diagram, we have a Y on the left plus 3 extra ones, and that's balancing or equal to 1, 2, 3, 4, 5, 6 ones. And my goal is to figure out what Y equals. Well, I want to get Y all by itself, so if we cross out the ones that are matching, that means Y is equal to the 3. And so we have to take away the 3 from the left side with the Y and the 3 from the right side, and we end up with Y equals 3. Now we're just using our equations. In our left side diagram here, we have x plus 3 on the left and 8 on the right, and those are balanced. I need to get the x by itself, so I'm going to take the 3 from the x side and the 3 from the right side, and we get x equals 5. And finally, this one, we have 13 and 4/5 on the left. It's balanced, so equals. And on the right, we have w plus 3 and 4/5. And I know to find w, I need to take 3 and 4/5 away from the 13. And to keep it balanced, I need to take the 3 and 4/5 from the other side of the equation. And we end up with 10 equals w. Now I don't have any ones on the same side as my variable. I have 3 x's on the left and 6 ones on the right, and those two sides are balanced, so we end up with the equation 3x equals 6. And we can use our math facts, and we know that x has to equal 2. Sorry here. 3x equals 6. And I know x equals 2 because I divide 6 by 3. But remember, to keep it balanced, we're really dividing both sides by 3. And we use the fraction bar to do that. This one is very similar, only this time my 6 ones are on the left and I've got 3z on the right. So if I divide this into 3 equal groups, I also need to divide the right side by 3 equal groups to match them up to get 2 equals z. That number that we're dividing by the number that's being multiplied in the equation. That number is called our coefficient. Our equation here is 12 equals 2y. So we divide by the coefficient. There are 2 y's, so I divide both sides by 2, and we get 6 equals y for our solution. The one on the right, we have an 11 on the left, and we have 4z on the right. So I need to divide the 11 into 4 equal pieces, but I have to divide both sides by 4. I'm dividing by that coefficient, and we end up with z is equal to 2 3/4. So we're undoing the operation that's given with its inverse operation. 4x equals 9. Well, this is multiplication, so to undo it, we divide. 9 divided by 4 is 2 1/4. Here, now I have x minus 10. So to undo subtraction, the inverse operation is addition. So x equals -5. X plus 7 equals 31. Here's my x. I want to undo the addition by subtracting. So x equals 24. Here's my x in the number 4. I'm multiplying by -7, so the inverse operation is to divide, and we get -5 equals x. And finally, now here I'm adding -9. I don't want to subtract 9. I want to get 0 extra on that side. It's like my house has 9 weights on it, and I need to bring it back to 0. So I'm going to add 9 balloons to both sides. And we end up with x equals 21.